For over a century, physicists have been intrigued by the idea of black holes, with the concept gaining traction around 1916. These cosmic anomalies are among the most captivating and enigmatic phenomena we know, sitting at the intersection of vast gravitational forces and a peculiar invisibility to our understanding. A black hole, potentially weighing as much as 2 to 4 million times the mass of our Sun, remains a mysterious presence in the cosmos. Despite decades of intense research, our understanding has expanded from almost no knowledge to piecing together more details. 32 seconds. Recently, a breakthrough by Michio Kaku has revealed startling insights about the interior of black holes, which may challenge our long-held assumptions and offer new perspectives on the nature of these celestial bodies. This new information opens doors to deeper explorations into what might have been overlooked until now. Join us as we venture further into the fascinating world of black holes and uncover what's hidden within the universe's vast and inspiring expanse. But what exactly are black holes? 1 minute and 3 seconds. Before we delve into the latest findings by Kaku, it's essential to revisit the basic understanding of black holes. While most of us have at least a general sense of what a black hole is, there are still some key elements that remain unclear. In 1916, Albert Einstein's groundbreaking theory of general relativity predicted the existence of black holes. At that time, the notion was purely theoretical. It wasn't until about 50 years later that evidence was discovered confirming that black holes are real objects in space. 1 minute and 37 seconds. This revelation came in the 1960s during studies of the star X-1, a luminous celestial body emitting X-rays. Observations showed that these X-rays were not just randomly moving but were being drawn into a dense, invisible mass. This mass, later identified as a black hole, changed our perception of the cosmos. The discovery was monumental, as it proved that black holes were not figments of Einstein's imagination but tangible, elusive entities that warranted further investigation. 2 minutes and 9 seconds. Following this groundbreaking discovery, scientists worldwide began a global quest to uncover more about black holes. Their efforts led to the realization that the Milky Way alone may host around 100 million black holes. However, due to the challenges in detecting them, this estimate remains imprecise. Even though black holes are incredibly difficult to pinpoint, scientists believe that millions of these massive entities are hidden within our galaxy, making it even more crucial to understand them. 2 minutes and 41 seconds. Let's break down the core concept: gravity. Black holes exert such immense gravitational forces that anything entering their domain is squeezed into a singularity, a point where the laws of physics, as we know them, cease to function. In simpler terms, black holes are like gigantic vacuum cleaners, pulling everything into them. One of the most terrifying aspects of studying black holes is that if someone were to fall into one, they would gradually stretch out and become a singularity, their body torn apart by the intense gravitational forces before the point of total destruction. 3 minutes and 11 seconds. It's best to avoid getting too close to one, though they are scattered across the universe. Despite the nearest black hole being nearly 500 light-years away, the proximity still raises legitimate concerns. In 2021, scientists achieved a historic milestone by capturing the first clear image of a black hole, the M87 black hole. This achievement was the result of numerous nights spent taking photos and aligning them to create a single cohesive image. 3 minutes and 45 seconds. As more data was gathered, researchers were able to discern that black holes consist of 3 distinct layers, contrary to the common misconception that they are just endless voids. 1. The event horizon. This marks the point beyond which nothing can escape. Once something crosses this boundary, it is inevitably drawn toward the black hole. 2. The photon sphere. This is where light itself gets trapped, unable to escape due to the powerful gravitational forces at play. 3. The singularity. This is where all matter is compressed into an infinitely small point, a place where the very fabric of reality collapses and all known laws of physics break down. 4 minutes and 17 seconds. What's even more intriguing is that each black hole is unique in its own right. While they follow the general 3-layer structure, the way they behave can vary significantly. This makes them particularly challenging to study, as conventional scientific methods don't apply. Scientists have no choice but to investigate these anomalies through indirect means, such as observing the radiation emitted from them or analyzing the gas and dust swirling around them. 4 minutes and 46 seconds. Sending a probe directly into a black hole is futile. Anything that crosses the event horizon is inevitably pulled toward the singularity, where it is crushed into nothingness. This unavoidable fate means that billions of dollars cannot be spent on probes that would meet their end before offering any valuable data. Consequently, researchers are left to study black holes in 2 dimensions, despite them being 3-dimensional singularities. 5 minutes and 17 seconds. Adding to the complexity of black hole research is the fact that no 2 black holes are identical. When studying them, we must account for the breakdown of physics as we know it. Theories about the origins of black holes suggest that they may form when massive stars collapse in on themselves. As a star burns through its fuel, it can no longer produce enough energy to counterbalance the inward pull of gravity, leading to its eventual collapse into a black hole. 5 minutes and 48 seconds. To further understand the nature of black holes, NASA scientists turned their attention to the center of the universe, particularly the M87 galaxy. There, whirlpool of hydrogen gas spinning at mind-boggling speeds of 1.2 million miles per hour. The centrifugal force should have caused this gas to fly apart, but instead, it remained intact, suggesting the presence of a massive object at the center, likely a black hole. This object is believed to weigh up to 3 billion times the mass of our Sun. Despite these groundbreaking discoveries, many questions remain unanswered. If black holes are among the most extreme objects in the universe, could they also be the key to understanding the fundamental nature of space and time? Physicists have long speculated that black holes might not just be regions of destruction, but could also hold hidden gateways to deeper cosmic truths. Some theories suggest that the singularity at the center of a black hole is not just an infinitely dense point, but a bridge to another part of the universe, or even another universe entirely. 6 minutes and 58 seconds. One such concept is the Einstein-Rosen bridge, commonly known as a wormhole. This hypothetical structure could theoretically link 2 distant points in spacetime, offering a shortcut through the vastness of the cosmos. If wormholes exist within black holes, could they be traversable? Recent research suggests that certain types of black holes, particularly those with a rapid rotation, might avoid forming a singularity in the traditional sense. Instead, they could create a ring singularity, a region where the laws of physics break down differently than in a static black hole. If this is true, such black holes could serve as natural portals through spacetime. 7 minutes and 32 seconds. However, even if wormholes exist, they come with major challenges. For one, they would likely be incredibly unstable, collapsing before anything could pass through. Theoretical physicists have proposed that exotic matter, material with negative energy density, might be needed to keep a wormhole open. While exotic matter has not been observed directly, certain quantum effects suggest that it might be possible. If future discoveries confirm its existence, humanity could one day find ways to stabilize wormholes, making interstellar, or even intergalactic, travel a possibility. 8 minutes and 4 seconds. Another intriguing question is, what happens to information that falls into a black hole? According to classical physics, anything that crosses the event horizon is lost forever. However, quantum mechanics suggests that information cannot be destroyed, leading to what is known as the black hole information paradox. In 1974, physicist Stephen Hawking proposed that black holes slowly evaporate over time, emitting what is now called Hawking radiation. If this radiation carries information about the objects that fell into the black hole, it would resolve the paradox. But if the information is truly lost, it would mean our understanding of quantum mechanics is incomplete. 8 minutes and 40 seconds. Recent studies propose a fascinating possibility, that black holes might not destroy information but instead encode it on their event horizons. This idea, known as the holographic principle, suggests that the 3-dimensional information inside a black hole might be preserved on its 2-dimensional boundary. If true, this principle could revolutionize our understanding of physics, hinting that the entire universe itself might be a vast, higher-dimensional projection of information. 9 minutes and 10 seconds. As our technology advances, new tools are being developed to test these ideas. The next generation of telescopes, such as the James Webb Space Telescope and the proposed Einstein Telescope, will allow scientists to study black holes with unprecedented precision. Moreover, advancements in quantum computing and artificial intelligence could help decode the complex equations governing black hole physics, bringing us closer to answers that have eluded scientists for decades. 9 minutes and 40 seconds. While we are still far from fully understanding black holes, each new discovery brings us one step closer to unraveling their mysteries. Are they merely cosmic endpoints, where matter is crushed out of existence? Or are they bridges to new frontiers of space, time, and reality itself? One thing is certain: the study of black holes will continue to push the boundaries of science, challenging our perceptions of the universe and our place within it. As we gaze into the abyss of these celestial giants, we may one day find that they are not just cosmic enigmas, but the very key to understanding the universe itself. With each new discovery, black holes continue to defy expectations. While they were once thought to be simple regions of inescapable gravity, they are now seen as dynamic, complex objects that may hold the key to understanding the very fabric of reality. But if black holes challenge the known laws of physics, could they also be linked to something even more mysterious, the origins of the universe itself? 10 minutes and 38 seconds. Some scientists believe that black holes could be connected to the Big Bang. The immense density of a singularity, where space and time cease to function normally, is eerily similar to the state of the universe at the very moment of its creation. A radical theory suggests that what we perceive as black holes might actually be reverse Big Bangs, where instead of everything exploding outward, matter collapses inward. Some even propose that each black hole could give birth to an entirely new universe, a concept known as the multiverse hypothesis. If this idea is correct, then every black hole could be a portal to a separate reality where different physical laws might govern existence. Could it be that our own universe was born from the remnants of another? 11 minutes and 15 seconds. While these ideas remain highly theoretical, new tools are emerging to test them. The Laser Interferometer Space Antenna, LISA, a future space-based gravitational wave detector, aims to measure ripples in spacetime with unprecedented sensitivity. By studying black hole mergers more closely, scientists hope to uncover hidden clues about their nature and potential links to the early universe. At the same time, researchers are investigating the possibility that black holes may not be completely black after all. Some suggest they could have a faint internal structure, or even be holographic shells that store and process vast amounts of information. If true, black holes might not be final destinations but rather cosmic archives, preserving the secrets of everything they've ever consumed. 11 minutes and 55 seconds. But even as we attempt to understand black holes, a new question emerges. Could they be artificially created? Advanced civilizations, if they exist, might harness black holes as energy sources, using their immense gravity to generate power through a process known as Hawking radiation extraction. Some even speculate that highly intelligent beings could manipulate spacetime to create stable wormholes, enabling instantaneous travel across galaxies. Could this explain some of the unexplained cosmic phenomena observed in deep space? Are we simply looking at black holes the wrong way, seeing them as natural objects when they might, in some cases, be artificial constructs left behind by ancient civilizations? 12 minutes and 30 seconds. As our understanding deepens, one thing is clear: the story of black holes is far from over. They are not just points of destruction but gateways to the unknown, hints of physics beyond what we currently comprehend. Perhaps, in the distant future, humanity will unlock the secrets of black holes, stepping beyond the boundaries of space and time into a new era of discovery. Until then, they remain the universe's greatest mystery, silently.